Okay, so we are going to be starting our little tutorial right here. As you can see, I have the questions on the board, and we're going to start with a quick little reminder that a fraction is comprised of two different parts. You have the numerator, so we're going to call this x. This is the numerator. This is the number that is being divided, and then you have the denominator, which we will call y. This is the number that is dividing x, also known as how many times can this number go into this number. Yes, so denom. So as you can see here, we have a bunch of problems. I'm going to quickly zoom in. We can get started on the first one. When it comes to addition and subtraction, you want to make sure that the denominators, let me use a highlighter instead, that the denominators are the same. If they are the same, then it's just simple. You can almost break it into two parts. So for this one in particular, let me make it even smaller. For this one, we have 8k plus 9 over 18 minus 2k plus 1 over 18. So since they're both over 18, what we can do is simplify it to this. So we now have 8, so equals 8k plus 9 minus, you're going to put brackets around this one, minus, open bracket, 2k plus 1. And since, like I said, since these are the same, it just can be equated, so it just goes right there. So this is all over 18. So once you get here, you can rearrange so that you have like terms close to each other. So you're going to have 8k minus 2k. You're going to have positive 9, and then this negative will multiply into the bracket and will make this a negative, and you will have minus 1. Then, once again, that is over 18. So simplifying this, we're going to have 8k minus 2k, which is equal to positive 6k. And then positive 9 minus 1 is going to be positive 8. And it will remain over 18. However, as you can see, all of these terms are even, so that means they are divisible by 2, basically. So we can simplify the fraction by dividing out. See, this is the step that I'm not sure if your school will recommend you to take, but I'm going to write it in red. An extra step. Extra. It's a little jarring, my bad. Extra is since 6k plus 8 and 18 is, they're both divisible by 2, you can factor out the 2. So you can do 2, and then you're going to do 6 divided by 2 is 3k, 8 divided by 2 is positive 4, and 18 divided by 2, you're going to factor it out on the bottom as well. 18 divided by 2 is 9. So now what you have here is basically, if this was multiplied into the brackets, you would have exactly what you have up here. So since this is a fraction and it is still a division problem, these two can cancel. So you will be left with, in finality, 3k plus 4 over 9. And as you can see, it cannot be reduced any further. All right. I'm going to shift this over, and I'm going to probably write it in a different color because it's a little bit hard to make out from what I can tell. So there's our first question done. Oops, I missed the bottom component. Anyways, while I do that, I'm going to start talking about the next problem. So question 2, you can see, is similar. It has the same denominator, so that makes it really nice and easy for us. So it's going to be a very similar process of just equating the numerators, equating these two, and then setting the denominator to be the common denominator. It's not letting me change the color all of a sudden. There we go. Alright. So I'm gonna, since the red was a little bit hard on the eyes, I'm just gonna highlight the final answer. But like I said, I'm not sure what your school requires you to break it down to, so we're gonna highlight both. So, once again, as you can see, take a second to pause the video and see if you can try and write out what this one will be. Okay, so we have 9w cubed. I'll read out the question. 9w cubed over 2w to the 5 plus 3w cubed over 2w to the 5. So 9w cubed plus 3w cubed over 2w5. This is going to be, we don't even have a secondary number like we did in the first one. So all this is going to be is 9 plus 3. So that is going to be 12w cubed over 2w5. So, sorry, qw to the 5. My exponent was a little small there. So, like before, we can also reduce this because 12 is divisible by 2. We don't need to look at this, although we could. So, basically, this can be broken into two parts. We have 12 over 2, and we have w cubed over w5. So 12 divided by 2 is pretty simple. You're going to have 6. Since it's still going to have, since the numerator is smaller than the denominator, 3 is less than 5, we are still going to keep it as a fraction. So for ease of understanding, I'm going to write 6 over 1, which is the exact same thing. So this will cancel out. I believe, I will double check right now actually, but I believe the 3 will cancel with the 5. So when you're dividing exponents, it becomes, so yeah, when you do w3 divided by w5, it basically becomes this. It's equal to w3 minus 5. So what you're going to have is w to the negative 2. See, something that you're going to learn further along in math, should you continue to take it, is that a negative exponent, like you don't need to remember this, but a negative exponent just means that it needs to be, if this is in the numerator right now, the negative exponent means that it needs to go to the denominator. So it will become 1 over w squared. The way that my teacher explained it when I was in high school is that if it's a negative exponent, it's not happy where it is. It's feeling negative, so it needs to change spots. So same sort of deal goes where if you had if your equation left you with 1 to the negative 2, this implies in the denominator, it implies that it would go back to the numerator, and that would change it to a positive. Whoops. Then it would become positive there. But to just work with what we have here, this basically indicates that we have this, this became w to the negative 2, which is equal to 1 over w squared. So, subbing this in here, that's an arrow, we get 1 over w squared. Therefore, when we multiply these together, because we split these into different components, like I said, this is a little bit of a convoluted way of doing it. I'm just trying to explain it as best I can and as like in the simplest form. If you wanted to do it all together, you absolutely could, but I just wanted to split it up so that we could have the components with a polynomial or with a variable, and then without. So when we multiply this together, we get 6 over w squared. I'm going to erase some of these arrows because I feel like they might be a little bit confusing. Is it equal to... there. And then this is the side note. Okay, so moving on to the next question. As you can see, once again, similar denominators. For that reason, I am not going to solve that question out of respect for everybody's time. This one, given the previous explanations, you should be able to work through. It is virtually exactly the same as the first, except the only difference is that now you have two variables. You have a y squared and a normal y. But like I said before, the denominators are the same. You just sum it over like this. Sorry, I'm going to highlight again. Just sum it over like this, and then add and subtract like variables when required. So, moving on to this one, as you can see, we have some differences going on. Basically, what this is a matter of multiplication. So, right now, we have a over 12b minus b over 8a is equal to what? So when you have terms that have unlike denominators, it is similar to any, it's literally the exact same process as if this was just 1 over 12 minus, I don't know, 2 over 8, let's say, right? Basically, these aren't the same, so you need to mess with the numbers. You need to perform some mathematic functions on it so that you have a common denominator. So, what we have here is 12b, and because we have an a, when it comes to working with variables in the denominators, especially unlike variables, what you do is you multiply the numerator. Here, I'll just draw it out. So what we're going to do is a over 12b, and then you're going to multiply it by the other fraction's denominator. So we're going to multiply it by this whole thing. So it's 8a. So that's going to be 8a over 8a. Now, the reason that this works is because you are basically multiplying it, and it will give you like terms, and I'll show you in a second what we're going to do to the second part. I hope you guys can see my mouse. But this 8a over 8a is equivalent to 1 because it cancels out. 8 divided by 8 is equal to 1. So then we're going to do minus b over 8a. And you see here, we're going to multiply. I'm going to circle it in a different color. We're going to multiply this by 12b. So we have times 12b over 12b. So once you multiply that in, you're going to have 8a squared times, that is going to be 96b a. And that's just 8 times 12. Minus, so you're going to have 12b squared, because you're multiplying a into the bracket. And then likewise here, you're multiplying b into the bracket. So you have b times 12b becomes 12b squared over, because we have common denominator, it's going to be this number. So we're going to have 96ba. Now, similar to the process for question 1, 2, and 3, Now that we have a common denominator, it's just a matter of simplifying. So we have 8a squared minus 12b squared over 96ba. So what we get from this, you can totally reduce it because, as you can see, everything, all of these are even numbers. 8, 12, and 96. I'm not going to reduce it, but it looks like you could reduce it by a factor of 4. Actually, I'll do it for fun. So this would give you, we're going up here, this would give you 2a squared minus 3b squared. Oop, that's not a very good 2. Minus 3b squared over 96 divided by 4 is 24. As you can see, we've reduced it as far as possible because 3 is not even and can no longer be divided by 2. So that's what this is. So as you can see here, it's going to be a similar process. Let's see. So we have 7 over n plus 9 multiplied by, I'm just going straight into it, 4n plus 36 over 4n plus 36 plus 12 over 4n plus 36 times n plus 9 over n plus 9. And that will give us, let's multiply this into our bracket. So from multiplying polynomials, we will remember FOIL. First, outside, inside, and then last. FOIL. So when we're multiplying our denominator, we're going to have n plus 9. Sorry, I'm going to erase this later, but to give you guys a better view of it, 4n plus 36. So our first is going to be n times 4n, so we're going to have 4n squared. Our O is going to be the outside, so we're going to have n times 36 plus 36n. We have inside, which is going to be 9 times 4n, which is going to be plus 36n again, and then 9 times 36. So that will be our last. Plus 9 times 36 is 324. So simplifying this, we get 4n squared plus 72n plus 324. All of these numbers, we're just gonna leave it as that. I'm going to move this to the side so that it's not in the way because we do have a limited amount of space. You should be able to factor this and figure out what it becomes in terms of, well, I mean, these are two things that are multiplied together. So I suppose it wouldn't do you any good. Alright. So basically what it would become is, like, it's not worth it to factor it out right now, only because the, it would just become n plus 9 times 4n plus 36, or if you removed the 4 from the entire bracket, so you divided the bracket by 4, it would just become n plus 3, and the 4 would be outside of the bracket. So there's no point, really, in divvying it up like that. So, once we get that, we're going to have all of our stuff. So, as you can see, we're going to, once again, multiply the 7 into the brackets. We don't need to do FOIL because there is no other term. So we have 7 times 4n, which is going to be 28n, plus 7 times 36. 7 times 36 is equal to 252. 252. My bad. 252. Plus, we have the same denominator, so I'm just going to extend that out. We have 12 times n, so that's going to be 12n. And then n times 9. So that's a 9, not an a. 12 times 9 is 108. Now, if we gather like terms, we're going to, let me just shift this up. All right, gathering like terms gives us 28n plus 12n plus 252 plus 108 over 4n squared plus 72n plus 324. And once we do that all, it gives us 28 plus 12 is 40n plus 252 plus 108 is 360. 360 over 4n squared plus 72n plus 324. So what you could do now, if you wanted to reduce the fraction, it's kind of what I said earlier about breaking it into the other stuff. Actually, no, you wouldn't even need to do that. You can just divide the whole term by 4. So, I'm just going to put a star number, I think that's number 5. You can reduce further. So we would get 4, take the 4 out, so you'd have 10n plus 90. Take the 4 out of the bottom, so we would have n squared plus, let me see, what's 72 divided by 4? 72 divided by 4 is equal to 18 plus 18 plus 324 divided by 4 is equal to 81. Once again, 4 and 4 cancel, so you get 10n plus 90 over n squared plus 18 plus 81. Okay. Yeah, that's as reduced as you can get it. So this is pretty much the same thing. I'm going to just do this one since I feel like this one requires not too much more effort, but it is a little bit more work. So for this particular denominator, as you can see, is a polynomial with 3 parts. We have the p squared. What's that called? I forget the exact term. Whatever. You have a p and a like b value. Or no, that would be the c value, sorry. You have an ax squared plus bx plus c. That's the same polynomial format. So, as we know, it can be factored into its original components. So, we're going to have this. Just from looking at it, it looks like this is something that you will need to develop on your own. Unfortunately, I cannot dedicate too much time to explaining how to do the factoring. Ideally, it's something that there are tons of other videos on YouTube that can help you out with that. So this screams -9. One of your numbers is -9 and the other is +5. So That's because these multiplied together give you negative 45, and these added together give you negative 4. So, whoops. So what this means is we are going to have p squared minus 9p over, this is the factoring, p minus 9 multiplied by p plus 5. So as you can see here, we already have p plus 5 in the other fraction. So we do not need to multiply, and we also have p plus 5 here. I'm just going to highlight that in case the similarity isn't seen. P plus 5 and p plus 5. That means we don't need to multiply this original big fraction by p plus 5 because it is already in the denominator. All that needs to be done is multiply this fraction here by p minus 9 because that is the component that it doesn't have. So that is going to look like 2 over p plus 5 multiplied by p minus 9 over p minus 9. So when that multiplies together, we get p, that looks like c. Oops. Need to draw my brackets a bit better. P minus 9 times p plus 5. And in our numerator, we are going to have p squared minus 9p minus, so we're going to multiply in our bracket here. So we have 2 times p, so that's going to be 2p, and then 2 times negative 9 is minus 18. Don't forget to add your brackets here. Oops. So, simplifying this, we get p squared minus 9p minus 2p plus 18. Because we have essentially a negative 1 that is getting multiplied into the brackets. A negative 1 times a negative number gives you a positive number. So p minus 9, p plus 5. So bringing like terms together, which we already have essentially done, we get p squared minus 11p plus 18. Yes, okay. Over p minus 9, p plus 5. I'm trying to think of what this can factor into. I'm pretty sure I'll leave that as a you question. Which numbers, if these can be factored together, what do they become? Or you could just change this back into the ax squared plus bx plus c format. Doesn't matter. Okay. I am going to just touch on this one is a little bit funky. This one here. This one, if you need assistance with it, you can write to me and I will send you the solution. But for the sake of time, I'm going to stick with this k plus 5 one. So this one isn't tricky at all. Basically, the whole idea is that this looks like it's just k squared minus 1, but it can be broken into an ax squared plus bx plus c format. I think that's called standard form. Yeah, I'm pretty sure that's called standard form. It can be broken into standard form, and because the biggest hint is that this is a minus 1. So it becomes k plus 1 times k minus 1. And this is true because when we use FOIL, we're going to do first k squared, first outside k minus k, or one, I'll just put minus 1k for consistency. Then we do plus 1k, and then plus 1 times minus 1, positive times negative gives you a negative. So essentially these cancel out. So k minus k, or negative k plus k, gives you 0. So once you factor that out, the question becomes solvable. It just becomes exactly like number 6. So you get k plus 5 over k plus 1, and I'm going to shift it over here, plus 8 over k plus 1 k minus 1. So as you can see, the factor that this is missing is k minus 1. So we are going to multiply k minus 1 over k minus 1. Now we have a common denominator again. So that gives us k. We're going to do FOIL again. Sorry. Actually, we could leave it. Nah, yeah, let's do FOIL. So we are going to do first, so we have k times k, so we get k squared. And this is for the numerator, by the way, not the denominator. K times k is k squared. K times negative 1 is minus k. 5 times k is plus 5, or positive 5k. And then 5 times negative 1 is negative 5 over plus 8 from this secondary fraction here. Plus 8 over k plus 1, k minus 1. When you bring like terms together and reduce, you are left with k squared plus 4k plus 3 over k plus 1, k minus 1. So the tricky thing about this one is actually that this can be reduced even further. So what we're going to do is we are going to pull it apart into its, I think it's squared form, or the going from ax squared plus bx plus c to x plus d x plus e. Whatever, this is standard, I think this is squared. So we are going to be doing this procedure here to this. So 4 times 1, sorry, 3 times 1 gives us 3, and 3 plus 1 gives us 4. So those are our numbers. As you can see, we have 3 and 3 and 4 and 4. So those are going to be, I believe those are called factors. So we are going to get, so 3 is going to be one of them and 1 is going to be another. So we're going to have k plus 3 and k plus 1. So do you see anything here where the top is equal to the bottom? Right now, we have k plus 1 in the numerator and k plus 1 in the denominator. This means that we can cancel these out. Because k plus 1, like when we multiply things in, like that, k plus 1 over k plus 1 is equal to 1. So our final reduced fraction is going to be k plus 3 divided by k minus 1. I will leave that there. Alright. So for this one, it is the same sort of process. Like I said, if you need any assistance, feel free to reach out. Will always respond to my WhatsApp or my email. But for the sake of time, we are going to probably just move on to this. So, I am going to write over the majority of what is written here, just so that we have a blank canvas. All right. Probably should have done that before. My bad. Division and multiplication are by far the easiest because there is no, like, multiplication. You know how in the addition you had to find a common denominator, right? Like you needed to make the things on the bottom equal. Not anymore. This is literally just multiply it together. So, looking at this, we have k squared minus 36 times k plus 8 over k minus 3 and 48 negative 2. I'm actually going to rewrite this in the proper format. So you get negative k squared minus 2k plus 48. So, I cannot immediately think of what this one simplifies out to. Let me just double check. Algebra. So, six times 8. Sorry. My silly, ooh, is it? Yeah, okay. So what we're going to do is we're going to pull the negative out. So we're going to take this, and we're going to put k squared minus 36. We're going to pull the negative out so that we have k squared plus 2k minus 48. So the reason that this is like this is because when you multiply the 1 back in, you will get all the same. This is equivalent. So when we look at it like this, it's a lot easier to see that k squared 2k negative 48. You are going to have one of the factors is going to be, so you're going to have k plus 8 and k minus 6. Just a reminder, minus 6, or 8 minus 6 is equal to positive 2, and 8 times negative 6 is equal to negative 48. And that checks off both of the boxes. That was just a proof of concept. Alright. So, I'm going to add the negative 1 here. And shift this back. Is equal to, is equal to. And as you can see, there is no k3 that is a common factor. So we're going to have k squared minus 36 times k plus 8 over, and we're literally just going to put we're just going to mash them together. We're going to have k minus 3. So I'm going to use highlighter to show where the different components come from. So as you can see, as we agreed upon earlier, k plus 8 came from here, and k minus 6 also came from here, and the k minus 3 is coming from up top. I'm going to write in the rest of the equation just so it's not confusing. K plus 8 over k minus 3. So we're going to use FOIL. So I'm just going to bring this up here so that we have some more space. actually, no. Is equal to FOIL, so we have k squared times, so first we have k squared times k, which is going to give us k cubed. You're going to do outside, so you're going to have k squared times 8, which is going to give you positive 8k squared. Inside is negative 36 times k, so we're going to have negative 36k. And then negative 30, so your last is negative 36 times 8, which is negative 288. And that's going to be over negative k plus 8, k minus 6, k minus 3. So bringing like terms together, actually no, there are no like terms in this particular instance. This is how it would be written in terms of formatting. There's nothing else that you can do. Oh, whoops. Back. There's nothing that you can do to reduce it. There's no like terms that you can add or subtract together. So, this final answer is over here. Alright. Now division, fraction division is really quite, it was my favorite because it is so simple. All it is when you have a over b divided by c over d, there's the hack. It's not even a hack, it's just how the math works. This is equal to a divided by b times d over c. So this is just flipping the second, or flipping the divisor, I think. The divisor, not the divisee. You flip the second fraction and then multiply it together. It is beautifully easy. So, in this particular instance, we have 6n minus 30 over 6, which we can reduce. Yeah, we gotta reduce this. Okay, so 6n minus 30 over 6 is, I'm just gonna put reduce. So, when you reduce it, we're going to take the 6 out. So, 6 open bracket. So, 6n divided by 6 is going to give us n. Negative 30 divided by 6 will give us negative 5 over 6 divided by 6. So, we're going to pull 6 out, and it'll just have, we'll have in brackets 1. So, 6's cancel. You get n minus 5 over 1. So now we get to basically put this back in, is what I'm going to say. I'm just going to shift this to the side. I'm going to shift this above so that you can still see what we did. Yeah, I'm going to write with that color. But it won't be right in the way. So then we go with our n minus 5 over 1. So that's going to be divided by, sorry, let me just write this in. N minus 5 over n plus 2, which is just what's written up here, is equal to, we have n minus 5 over 1. And we're going to do the flipping thing. So we're going to flip this. So it's going to be multiplied by, so our numerator, what's up here, is going to become what's on the bottom. So we are going to have n plus 2. And then what's on the bottom is what's up here on the other side. So then we're going to have n minus 5. We can put it in brackets if you want. So when we multiply that together, we get n minus 5. And we're going to keep it, we're not going to bring it into standard form just yet, times n minus 2 over n minus 5. And hey, would you look at that? Guess what cancels? Bang, bang. So what you're left with is n minus 2. That is your final answer. So the rest of it is pretty similar. It's a lot of factoring and finding out what is the numerator, what is the denominator's factored parts. I'll do, I think, if I have the hardest one, quote unquote, I don't know. Let's do one with a bunch of terms in it. Yeah, let's do number 6. I'll do number 6 and then I will end the video here, or end the video there. So, as you can see, we have 8 over r squared plus 7r plus 6 divided by 8 over 8r plus 8. So there are two things that we need to factor. We need to factor the denominator of the first fraction, and we need to factor the denominator of the second fraction. That will just make our lives easier. So, when we have r squared plus 7r plus 6, this is very similar to what we saw when we were solving... Oh, where did my little scroll bar go? No. Well, in a previous question, I think it was our factors were 3 and 1. And 3 times 1 gave us... 3 times 1 gave us 3, and 3 plus 1 gave us 4, and that was our... It was x squared plus 4x plus 3. Yeah. So, it's very similar. As you can see, we have 7 and we have 6. So, basically, whenever there's a factor of 1, the number in the middle here, the one that's just multiplied by like the variable with no exponent, is going to be 1. If it's 1 higher, it is going to be 1. That is my life hack to you in terms of math hack. So we are going to have r plus 1 times r plus 6. And that is going to be 8. And then when we reduce this, this becomes, we can factor out 8, so we do 8, and then we have 1 at the top in our numerator, and we bring out 8 from the bottom. We have r plus 1 here. 8's cancel, leaves us 1 over r plus 1. I'm going to move it over a little bit since it kind of falls in line with the edge of the paper. Alright, so when we put this back into our equation, we are going to get divided by 1 over r plus 1. Now if you remember, we are going to do the flip, so that means we're going to do 8 over r plus 1 times r plus 6, and then we're going to do multiplied by, so our denominator becomes our numerator, so we're going to have r plus 1, and our numerator becomes our denominator, so we're going to have that over 1. So, whoops, I suppose I can't undraw that. Anyways, when we multiply that together, we are going to have 8 times, we're going to keep it in brackets, r plus 1 over, and 1 times r plus 1 times r plus 6 is just the same thing. It's just times 1, so it doesn't change. Times over r plus 1 times r plus 6. And would you look at that? Once again, we have factors in the numerator and the bottom and the denominator that are the same. So what are we going to do? Once again, we are going to cancel them. So in the end, we are left with 8 over r plus 6. That is our final answer. Okay. Yeah, if you need any more assistance, I'm going to call it there because my voice is starting to give out. Yeah, I'm happy to explain or send me a message or email me. Yeah, just let me know, and I hope this was of assistance to you. All right, take care.